Hello, welcome back. Today we're going to be factoring special factors. By the end of this video, you should be able to quickly factor 4 different types of polynomials. As a note, to factor any polynomial completely, which is what we're going to be doing, we must first factor out the greatest common monomial factor, if there is one. We're going to take a look at a couple of vocabulary words, the first of which is the standard form of polynomial. To write a polynomial in standard form, you need to list the terms of the polynomial, from largest exponent to smallest exponent. Based on this definition, which of the polynomials below is listed in standard form? The answer is the first one is listed in standard form because the polynomial has been listed so that the largest exponent, x to the third, comes first, then x squared, then x, then our constant, which has no variable attached to it or with it. This one's not in standard form because x squared comes before x to the third. Our second vocabulary word to look at is the leading coefficient of a polynomial. The leading coefficient of a polynomial is the coefficient of the term with the largest exponent. So we're going to find the leading coefficient of the polynomials below. For the first one, we look for the term with the largest exponent, with the variable with the largest exponent. And we look at this one, we see that we got a 4x to the third. That x has the largest exponent of this polynomial, so our leading coefficient is 4. For this polynomial right here, our leading coefficient is going to be negative 1. Now, the 1 is understood to be there even though it's not written. And it is the leading coefficient even though it didn't come first because it came, or is the coefficient rather, of the variable with the largest exponent. So the first type of polynomial we're going to look at factoring quickly is a trinomial in standard form whose leading coefficient is equal to 1. If this is the situation, we can factor this polynomial by finding two numbers that multiply to the last term and add to the middle term. We can do this fairly quickly at first by listing factor pairs of the last term. The faster you get at this, the less you'll actually have to write down. But for right now, what I'm going to do is I'm going to follow that little hint or that little note right there to list the factor pairs first of the last term. And what I'm looking for are factor pairs of negative 24 that add to negative 5. I'm not going to be concerned with the negative portion right now. All I'm going to do is list all the factor pairs of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we could keep going, 8 and 3, 12 and 2, 24 and 1, but since those are repeat pairs, I'm not going to list them. Now we're going to look at each of these pairs and see if we can find a pair that will somehow add to negative 5 and multiply to negative 24. Looking at it, 1 and 24 will never add to give me negative 5. It doesn't matter if the 1 is negative or the 24 is negative, or if they're both negative, again, it will not add to negative 5. Now we can look at the 2 and 12. 2 and 12, again, will never add to negative 5. If it was negative 2 and positive 12, we'd get 10. Positive 2, negative 12, we'd get negative 10. 3 and 8 will add to negative 5 if we make it a positive 3 and a negative 8. Once we identify our pair, we must make sure it also multiplies to negative 24. Positive 3 times negative 8 does multiply to negative 24. So our factors are then x plus 3 and x minus 8. And I was able to find the factors of x squared minus 5x minus 24 just by identifying the factors pairs of 24 that add to negative 5. Go ahead and try to use this same method on your own to find the factors of a squared minus 7a plus 12. Pause the video. When you're ready to see the answer, please press play. Now, some of you may have been able to work this out in your head, but for right now, I'm going to go ahead and list all of the factor pairs of 12. 1 and 12, 2 and 6, and 3 and 4. Now I need one of these pairs to somehow add up to negative 7. 1 and 12 will never add to negative 7. It'll either give me 13, negative 11, or positive 11. 2 and 6 also will never add to negative 7, but 3 and 4 will, if I make it a negative 3 and a negative 4, because negative 3 plus negative 4 is negative 7, and negative 3 times negative 4 is positive 12. So our factors are a minus 3 and a minus 4. Just like all the other types of factoring, you can always check your answer, which is a good idea if you have additional time at the ends of quizzes or tests, by distributing. So a times a, so we're going to check our answer right now, is a squared. A times negative 4 is negative 4a. Negative 3 times a is negative 3a. And negative 3 times negative 4 is positive 12. This gives us a squared minus 7a plus 12. If, when we distribute, we end up with the same expression we had to begin with, then we know that we factored correctly. Notice a squared minus 7a plus 12 is indeed our first, or our starting expression, so this means that we did factor correctly. The second type we'll look at is a difference of squares. If we have a difference of squares, we can factor by taking the square root of the first and last terms. That's not a complete set of instructions, it just gets us started. So, looking at this first example, you'll notice that 36x squared and negative 49y squared both have square roots. 36x squared will factor out as 6x and 6x. Negative 49y squared, so we're going to look at just the second term, the positive 49y squared portion. Square root of 49 is 7, and the square root of y squared is y. We end up with a plus 7y and a minus 7y because we have to multiply to give us a negative 49y squared. So the way we do this is, first we take the square root of the first term, that goes in our first term spots, and we take the square root of the second term, and that goes in the last spots, and we do a plus and a minus in between the two. This is really just a shortcut to factoring by other methods, but if you notice this pattern, it will work this way every single time. Go ahead and try to factor 144m squared minus 25 on your own, pressing pause, and when you're ready to see the answer, please press play. Alright, the square root of 144m squared is 12m. So for both factors, 12m should be the first term, and square root of 25 is 5. So 5 should be the second term in both factors. One of them positive, one of them negative, because they have to multiply to negative 25. We can always distribute this to check our answer, but here you go. Very little work involved in order to factor what's called a difference of squares. Difference meaning subtraction between two things you can take the square root of. Our third type of polynomial we're going to take a look at is a sum of squares. A sum of squares cannot be factored. Sum meaning adding, squares meaning two things you can take the square root of. I've written a note that says even though a sum of squares cannot be factored, you still have to factor out a GCF if there is one. GCF meaning greatest common monomial factor. So let's take a look. 4m squared plus 49. There is no common factor, so we cannot factor this polynomial at all, and we say it is prime. For our second example, there is a common monomial factor. It is 25. We can factor 25 out of both terms. So we get 25 and then b squared plus 4. Notice b squared plus 4 is a sum of squares. B squared being a square and 4 being a square. Since b squared plus 4 is a square, we cannot factor it any further. And our final answer is 25, parentheses, b squared plus 4, parentheses. I chose this example to show you that even though the sum of squares cannot be factored, we still have to factor out the greatest common factor and then write our final answer as it appears here. The last type of special factor we're going to be taking a look at today are perfect squares. If we're given a trinomial whose first term and last terms are perfect squares, meaning they have square roots, we can factor by taking the square root of the first and last term. This pattern will work most of the time. Should have added a little note that there are occasions when this will not work. Now, I've given you a couple examples here, and I'm going to do the first one. 81r squared minus 36r plus 4. We can factor this by taking the square root of the first term, 81r squared, which gives us 9r and 9r, and the square root of the last term, 4, which gives us 2 and 2. We know that our last terms have to multiply to give us positive 4, but our middle terms also have to add to give us negative 36, so we know that both of these have to be negative. If it was a positive 36, then it would be plus 2 plus 2. We can list this as 9r minus 2 squared. So to factor 9m squared plus 30nm plus 25n squared, I ask you go ahead and try this one on your own, pressing pause, press play when you're ready to see the answer. So again, we notice that the first term, 9m squared, and the last term, 25n squared, both have square roots. So there's a really good chance, and in this case it'll work, that we can factor by taking the square root of the first term. Square root of 9m squared is 3m, and the square root of 25n squared is 5n. Now, we want the two last terms to multiply to positive 25n and our middle terms to add to a positive 30nm. So it's going to be plus 5 and plus 5, which we can write as, by the way, this is an acceptable answer, but we can also write this as 3m plus 5n squared. If we want to check our answer, we must distribute using our two sets of parentheses, and I'll leave that up to you, but please go ahead and distribute that to check to make sure that these are the correct factors of 9m squared plus 30nm plus 25n squared.